Are we starting it?
Yes.
Okay, the first thing you do when you start LearnHVAC is enter your name in, and we're entering guest, which lets us run the default scenario. We start the scenario, and here we have the scenario starting up. Once it loads, the first thing you do is go to a better screen position, go to the mixing box. Here's the mixing box, which is where the air will come in and go out, and you start the simulation. Has been started, and the pink or red balls show hot air, blue show cool air, and the colors change accordingly. Here we see the incoming air at about 24 degrees C coming through the heating coil, which doesn't need to operate, but we're going to the cooling coil, and we want the air to be more like 15 degrees C coming into the space. So the cooling coil is operating at a modest level of valve opening, and here the cool air is now coming over the fan. There is the fan motor is in the airstream, and it adds a little bit of heat to the air, and we have our temperature in the space, or in the ductwork, is 15 degrees C. We now have a VAV. This is a variable air volume system that we're looking at, not widely used in Vietnam, but widely used in the US. We see the damper level, and there's no reheat in the VAV. We're watching the airflow coming in through the cooling coil up in the upper right into the fan. We see the whole system view as the animation comes through. We see the air coming down through the VAV box, down through the diffuser into the space, and the heat from people, lights, and equipment in the space raises the temperature up to the approximate desired set point of 24 degrees. So this is the way this system is operating. When the air comes back to the return air duct, the air can either go to the left out and be exhausted or return back. The dampers are set at 90% return air, 10% exhaust air. Okay. Now changing increasing the temperature of the outside air and the humidity, and we'll see that the major impact of this is that the cooling coil is now has its valve position open almost to 100%. This is about the limit of what this system can handle. So cooling coil is at 100% at that point. So here we see the dampers are still 10% open from outside air, and you see we're still maintaining the cooling set point of the system. So this is a very good description of how a basic HVAC variable air volume system works. We see the air flowing into other ducts, or other zones which we're not showing in this version of the program. Here we're looking at the whole system coming through. We are now going to look at another aspect and see all that. Yes, so we're changing the outside air and adjusting it a bit. So here we see the valve has gone down from 100% down to 75. We're now going to demonstrate one of the faults. You can have things that go wrong with the system, and this program lets you analyze them. So we have a leak in the boot of the valve in the heating coil, and this is a summer condition. There shouldn't be any heat on in this system, but because there's a leak, there's actually 50% of the flow is coming through the heating coil. So the heating coil is actually heating the hot air coming in. The air is coming in at 24 degrees C. The heating coil is going to heat it up to about 29 degrees C, about 5 degrees C, and you can see there's modest flow coming through, and you can see it's going from 24 to 29. And then the cooling coil has to work harder, cooling down from 29 C to 14 or 15 C. So we see we have a system really functioning in first heating and then cooling. Now this is an example of a fault that can have disastrous consequences for the efficient operation of the building. So we will now go and remove the fault, and we will next show you how to lower the outside air temperature to a condition. We're removing the fault now, and we're now going to go to our system level again, and instead of having a cooling condition, we're going to take the temperature of the outside air down to 10 or 15 degrees to show you a free cooling situation where you can actually have air coming in at around 15 degrees. You don't need to cool it at all. You just bring it in through the system and bring it into the space, and that's what's occurring here. The damper, the outside air damper, is almost 100% open. It's 75% open. So you're getting some return air to get the proper temperature in the incoming airstream. That's what you're doing there. And this is a pretty good summary representation of what we have in mind here. So I'll stop talking at this point.